Да, и вот сейчас передаю полностью его слово.
Thank you. So, first I want to say thank you to Melissa for her presentation. I'm a Russian-speaking guy, but I will present in English. Excuse me for that, but it's with respect to the organizers and our guests who came to us from Europe and organized this event for us. My name is Yuri Kunash. I'm a technical lead in Seavus and Banking and Finance Division. And my presentation today is about the communication, like the ways and technologies which we use for our service communications as alternative to HTTP and REST. So if you need to create a new service as a .NET developer, which framework or technology which will you think first? I believe it will be ASP.NET Web API or ASP.NET Web Core. But the truth is that HTTP 1 protocol and the JSON messages which are used by default there, they are not always the best choice for your services because they have some backsides. The first and the most important backside which I see is that you need to create some kind of wrapper to send the HTTP request with this, right? So what your wrapper should be able to do first, it should find a URL to which it should send the request. And in your application, you have namespaces, classes, and methods, and the URLs. They are different things. They are just the strings, and you need to have some kind of mapping between the methods which you have in your applications and the URLs. The next thing which your wrapper should be able to do is to serialize the payload. And if you think that serialization is free, it's not always so. It just depends on the size of the messages and on the quantity of these messages. You need to configure the request object to set up maybe some headers to choose this request object from the plenty of objects which we have in C# and .NET. And then you are sending the request. When you've got the response, you need to check the status of the response. If it's 200, you will read the response and deserialize it back from JSON to the object. And besides that, the serialization itself is it takes some time and it has processor cost. Another backside in HTTP and REST is that there is no strict typization, right? If the contract is changed on one of the sides, you will usually not know about it unless you send a request and will get an error. So what can be an alternative? Previously we used to have a WCF in .NET framework. Who is not familiar with WCF? I see some young guys here, maybe they haven't had a chance to work with WCF. WCF is a Windows communication framework, which is Microsoft technology provided for building service-oriented applications. And what WCF can is it can make remote procedure calls. It means that you can create some classes on the server side, extract the interfaces from these classes, share the interfaces with the client, and by that the interfaces will be the contracts. And automatically some proxy classes will be created on the client using from these interfaces, which you can use for calling the methods from these interfaces and from this implementation, which is sitting on the server. And when calling these methods, you will not see actually the difference between the calling these methods which are working on the remote server and the methods which you are usually calling locally in your application. Yeah, but we don't have WCF and Windows Communication Framework in .NET Core, right? At least we don't have yet. And what can be an alternative in .NET Core? And it can be gRPC, but before I jump into the gRPC, let's talk about let me introduce you the protocol buffers. Protocol buffers is an open source high performance mechanism for serializing the data provided by Google, invented by Google. So it's just another, it can be considered just like another format, and it can stand in one line with XML and JSON. I will give you now some more details how protocol buffers, what protocol buffer is. Let me just quickly introduce the sample application which I will use today in my presentation. So imagine that we are building just a simple audit service which have just two methods, log event and report. Log event receives some messages from the applications which you have all across the enterprise, and report just returns some collection of the previously logged events. And log event has an input, is a simple class with 4 properties, and as a response, it returns also a simple object, and the report method has no input and just returns a collection of events which were previously reported. So I will show you now this event info message serialized into different formats, and can you believe that if you serialize it in protobuf, it will be almost 2 times smaller than JSON. In fact, it can be, you can see here the numbers that, here is the protobuf message. It took only 52 bytes, and it's actually the very same message encoded just in different formats. And you can see that the protobuf is more than 2 times smaller than the SOAP message, and it's 4 times smaller than plain XML, and even 2 times smaller than JSON. These characters here displayed as they are standing out as just some bytes which are not in the Unicode char set. So you see that this protobuf message contains almost only the data, only 2 bytes, only 2 additional bytes we have ahead of the data, which describe actually the data type and the data length and the property number. But how is it possible that this metadata in the message can be so small? The first essential thing here is that in protobuf messages, we don't have the property names encoded like we have in JSON, for example. All the fields, actually, it's more correct to say fields, but not properties, because we have properties in the C# classes, but we have fields in messages. So all the fields in the protobuf messages have their numbers, and its field number is one of the things which is encoded in these 2 bytes. Another thing which is also presented in these 2 bytes. So here you have you can see these 2 bytes. Like I will describe them now. But besides the field number, another thing which is encoded in these 2 bytes is the field data type. Protobuf supports several data types. There are like the most commonly used, most frequently used of them, and each data type also has its number. So 0 for integers, 1 for double, and 2 for strict binary. So let's look into these 2 bytes which we have. So these 2 bytes actually are represent these 2 bytes which we have ahead of this value. This value looks like date, but it's actually a string in my example. And this first byte describes the data type and the field number. The last 3 bits of the first byte describe the data type, and since it's string, you can see that string is actually has number 2 in protobuf according to protobuf encoding rules. So the value 2 is encoded here in these last 3 bits. The rest of the bits contain the field number. So since this field number is 1, we have value 1 in the rest of the bits of this first byte. Next, the second byte. Since our value has 8 symbols length, and each symbol in Unicode character is just a single byte, so the length of the value is 8 bytes. So that's the value which we have in the second byte ahead the value itself, right? So in this second byte we have number 8 encoded. It means that the parser will read the next 8 bytes of the message as the actual value. Okay, for our, just for another example, for our second value, it also has string type. So again, we have number 2 encoded here in the last 3 bits. Then the number of this value is 2, so we have value 2 encoded here. And the length of the value is 14 bytes, so we have 14 encoded in the second byte. This is the second byte, and the parser will read the next 14 bytes as the value of the field. How the parser and serializer can know by the field number to which specific field of the object to set this value. So another required thing which we need to have when we work with protobuf is the protofiles. These protofiles is just the text files which describe the messages, and these protofiles should be located on the server. And in this since XML messages and JSON messages, they are self-descripting, but the protobuf messages, they do not have value about the names of the properties. That's why you need to have something like this on the server, which will actually help your application to map the values which you have in the encoded protobuf messages to the properties of the classes. And this is called protofiles. To create to use these protofiles and to create you can create the C# classes right from this protofile. For that, you just need to use a protocompiler. You can download this protocompiler from the internet and configure the C# classes would be generated every time when you build your application in Visual Studio. Let me show you a quick demo with this. So here, if the font on the right is too small, I think it should be recognizable. But here I have just a couple of these protofiles which describe the messages. And I downloaded the protocompiler from the internet, configured it in the system variables, so the proto-C command to be available from the command line, and configured the project's post-bill events, where I specified the path to these protofiles, and also another parameter is the path to the folder where the output C# classes will be generated. So now, once I build the project in this audit service, should appear the C# classes which will be automatically generated by the protocompiler from these protofiles. Yeah, you see they are here. We'll look into them now, but yeah, one important necessary thing here is that you need to also install the Google protobuf NuGet package in your project. So because the classes and the interfaces which are defined in this NuGet package, they will be used in the messages which will generate it. So this is the C# implementation, C# representation of these messages. I will show you now how we can work with them. Let's just briefly look inside what the protocompiler generates for us inside of these messages. So one of the first properties is parser, which actually can be used for parsing the protobuf message from the binary format back to an object, to an instance of an object in your application. The descriptor properties returns the descriptor, so you to be able to work with the protobuf instances using reflection. Next, there are our fields. So timestamp is the first field. So you remember, yeah, we just once again, I will repeat that we review in this event info class, which is generated from this event info message, which is declared in the protofile. So timestamp is the first field, and in C# created as a public string property. And there is a constant, public constant, which has the same name as the field, but just suffixed with the field number, and it has value 1. It's just because we specified value 1 here for this field as a number of the field. We can use any numbers. It's not necessary to have the numbers in order. Okay, so the public properties for all the fields are generated. Some usual service method equals generate get hash code. ToString method of the object will return a JSON representation of your object. Write to method is used as an opposite to the job which parser does. So write to is used for serializing from the instance of your object to the protobuf message. Calculate size method returns the value, the number of bytes which you will have in the serialized message. And message from methods, they are just used for merging the content from another protobuf message into your object, but these methods are usually used by the library developers and by the parser. Okay, so let me show you how we can create the protobuf message now in C# code. Okay, so I have this method here. What this method does is creates event info object, which we've just reviewed. This object, this type, is automatically generated by the protobuf NuGet package. Populates the properties of this object with some values. Okay, this I have here only to write these objects to. Yeah, okay, we need to create a stream, and then using this write to method, which was generated in the event info object, this method will write, will encode will serialize our event info into the stream. Here I just saving this stream to file just to show you the size of the messages in the demo. And then to deserialize back from the binary message to the object, you can call this static parser property of event info class, and it's parse from method and pass the stream to the which will read the protobuf message. And yeah, since when we serialize into JSON, we usually get a string as output. Here we have to work with streams since protobuf is a binary format. The second method which I have, yeah, and this method just repeats the same for several times and writes the content to the file. The second method does the same, but it uses the JSON, like Newton JSON library and JSON convert serialized object method, and writes the JSON to the file. Let's run the demo and see the difference in time, how faster it will be to serialize to and back from protobuf message, and how much time it takes in case with JSON, and also how big the size of the messages will be. Okay, you can see here that 100 messages was created, and when we were using JSON, it took a little bit more than a second. And protobuf serialization, like multiple times faster. And the total size of the messages also 2 times bigger with JSON than with protobuf. So that's actually it with protocol buffers. So protocol buffers are small and fast. And now we can go to and if protobuf gives you the messages, the gRPC gives you everything else for your services. It gives you the server services, like base implementation. It gives you client and communication channel. What we need to have to declare a service, to add a service to the messages. This is an example of the service declaration in the protofile. So here's our audit service, which has 2 methods, log event. We are specifying the input of this method and the return value. And that's actually it. It's all what we need to do in the protofile to declare the services. And this protofile should be compiled as well, and a different compiler should be used, not that compiler which we used for compiling the protobuf messages only. Since it generates a service, this compiler can be installed as another NuGet package, which is Google gRPC. Let's look into which artifacts will be created by this compiler in your application. So on the client side, let's start with the server. On the server side, the first object, the first class which will be automatically generated is the base implementation of this service, which will contain the virtual methods which you've declared in the protofile. And of course, you need to create an implementation of these virtual methods. Nobody else but you will be able to do that. So for implementation, you will create an implementation class and just inherit it from the automatically generated service-based class and override the method and put the implementation inside. And another another class which comes with the NuGet package is the server class, which will contain the definition. Once you create an instance of this server class, you will bind this service to the service implementation, specify the port numbers, and just start the server. And you can start it under console application or under Windows services. And after calling the start method, it will listen the incoming requests. What we have on the client we have a channel which is provided by NuGet package, Google gRPC NuGet package. And for creating an instance of a channel, you just need to specify a URL which will point to the server which is sitting on the different machine. And the audit service client is actually a stub which is called client. It's like the word client is used for, in WCF we had proxy. With gRPC we have a client which is automatically generated by the gRPC library. And you're just creating an instance of its client, pass the channel as a parameter to an instance of the client, and you will have these two methods on your client, and you can just call them as you regularly do with your C# methods. And what's good here is that by default, gRPC uses HTTP2 as a communication protocol, and with that it can provide you one great feature. So here are the examples of two different ways of communication. The first one is what is called unary calls in gRPC. When you init the request, then send one message, and then complete the request. The server waits, like the client waits, and the server processes, make some job. Then this server, as a response to this request, inits the connection, sends one message, and sends the status. Another approach, another like communication style, which can be used here is what is called streaming in gRPC. And with streaming, you can init request only once, then send infinite number of messages, and like not infinite, but any number of messages, and then to complete the request. And after the server processed all these requests, or like even during the processing these messages, the server can already start pushing the responses back to the client. Let me show you how it works, and also we'll review again the performance of using gRPC communication approach according to the classic ASP.NET applications. Again, I will just quickly show you the protofile which I have under my project. Here are log events and report methods, a couple of more methods which I'm not presenting right now. And once we run the compiler, by the way, now we shouldn't even configure the compiler. With gRPC, we shouldn't configure the compiler to be available from the command prompt. We just, it's enough just to install a gRPC tools NuGet package, and in the properties of the protofile to specify that it should be automatically compiled, that it should be compiled by the protobuf compiler, and this protofile will be automatically compiled each time when you build the application. After you compile the application, all these classes which we have seen on the previous slide will be created, and here's a sample of implementation of the service. So the implementation of the service just inherits from the generated service base class. And you see that the generated service base class provides the virtual methods which you can override in your implementation. And here in my case, what this method does is just receives the request and returns an instance of response and setting some data in the only single property of the response. And to run the server, to run the service, we just need to create an instance of the server, bind it to the server implementation, specify the ports number, and call and start. What should we do on the client? On the client, we are creating a channel. So yeah, I have it here the server and the service and the client under a single solution. Of course, the whole idea of the gRPC is that you can have the client and the service in different solutions and hosted on different machines. But it's just a demo. That's why I have everything in a single solution. So what we have in a client. What should we do for communicating to the server is just to create an instance of a channel, specify the URL to the server, and create a client. This client class is automatically generated by the Google gRPC library. Then we can just create an instances of the messages and just call the log event method like we usually do in C# code. And yeah, you will not see the difference here between the calling of this method. Even when you know that the implementation of this method and this method will actually be executed on the server side, not on the current machine. Let's run this demo, and we'll see the difference in performance between gRPC and ASP.NET applications. Let's wait a couple of seconds. It will, since it takes some time to communicate to ASP.NET application. Okay, we see now that 100 messages was sent from the client to the service. Yeah, so these first two lines, actually, it's the methods which have been executed by ASP.NET application, which is hosted under Kestrel service, under Kestrel hosting. And for 1,000 messages, it took 13 seconds to process these messages by Kestrel and ASP.NET when they have been serialized to JSON. It is possible to just use protobuf together with ASP.NET, and it gives you about 40% performance gain if you use protobuf with ASP.NET applications, right? So it's not necessary to use gRPC for having benefits of the protobuf mechanism. And if you just use gRPC, you see how big the difference is, how much faster gRPC processes the same quantity of the messages comparing to the ASP.NET. I think it's 20 times faster, right? And if we use streaming, it's even more faster. It gives you another 30% of 40% of efficiency. So that's actually it. That's the bottom line of my presentation. I just want to say that yeah, it's not necessary. It's not always the best approach to use HTTP and JSON as the style and communication technology for your services. There are some other tools and approach which as easy and maybe even easier to use to set up, and which will be able to provide you the better performance than the tools which we usually use. That's it.